Let's go remember all the formulas for electric charges. Force between two charges formula is 1 by 4 pi epsilon naught q1 q2 by r square. Electric field intensity formula is 1 by 4 pi epsilon naught q by r square. F is equal to eq. So dipole plus q minus q is subtracted by some distance. So dipole momentum formula P is equal to 2aq. Electric field on axial line 1 by 4 pi epsilon naught 2p by r cube. Electric field on equatorial line 1 by 4 pi epsilon naught p by r cube. Electric field due to long sheet E is equal to sigma by 2 epsilon naught. Potential energy formula 1 by 4 pi epsilon naught q1 q2 by r. Potential formula 1 by 4 pi epsilon naught q by r. So work done is equal to vq. W is equal to vq. Suppose charge is there at a distance d. It has electric field E and its potential is V. We know that V formula 1 by 4 pi epsilon naught q by r, but in place of r we take here d, and E formula 1 by 4 pi epsilon naught q by d square. So d square is nothing but d into d. Say 1 by 4 pi epsilon naught q by d. Instead of this one I take here v by d. V by d. So E is equal to V by d is also formula. Now the question is derive an expression for potential energy of electric dipole placed in uniform electric field. Now dipole is placed. Derive an expression for potential energy of electric dipole placed in uniform electric field. Look here, electric dipole placed in uniform electric field. So what is mean dipole? We know that dipole is plus q minus q separated by some distance. So dipole is located exactly at the midpoint. From the midpoint, plus q is away a, minus q is away a. So total distance is here 2a. Dipole moment formula product of charge and distance between two charges, that is P is equal to 2aq. Okay, already studied in the previous questions. Now what is mean uniform electric field? You know, uniform electric field is produced by taking two parallel plates. One has positive charge, other one is negative charge. Both charges are same. One has q, another one is minus q. So in between two plates uniform electric field is created. You know, electric field line start from positive charge and ended to the negative. Suppose these are field lines. So what is the question here? Suppose dipole is placed in the electric field. So now this is the dipole plus q minus q. is placed in the uniform electric field, it makes an angle theta naught to the uniform electric field. So due to uniform electric field, two opposite forces act at the end of poles. See, plus is repelled by this positive charge along this direction, and also simultaneously minus attracts the along this direction. Similarly, minus q attracts by positive plate along this direction. It simultaneously repelled by the negative plate. See here. So due to electric field, two opposite forces act on the dipole. When two opposite forces acted on the dipole, it get rotation. Suppose we take the example on water tap. So how to apply forces on the tap? So make with two fingers. You operate the rotation of the tap. With one finger, you applied suppose force along this direction. With other finger, you applied force in opposite direction. So here two opposite forces acted on the tap. So due to that, it is rotated. Similarly here, so two opposite forces acted on this one. So what is happening? It is rotated. So while here showing the uniform electric field, don't show these plates. It is not necessary showing this positive plate and negative plate. So this is represent the uniform electric field. Okay, not need to draw the parallel plates. See here, suppose dipole is rotated with some angle. Suppose this is minus q. Now it makes an angle theta to the uniform electric field. So here charges is moving from one place to other place in uniform electric field. So here dipole get rotated. We know that rotation is caused by the torque. When the torque produced here P cross E. In the previous question we studied this formula, torque is equal to P cross E. So what is this? PE sin theta. Torque is equal to PE sin theta. Work done formula, integration F dot dr. Lower limit is R1, higher limit is R2. Now the motion is in rotation motion. So these terms are compared in rotation motion. Already we have studied in the intermediate the first year in the chapter of system of the particles. Instead of force, we take here force is compared with the torque. Displacement is compared with the angular displacement. So R1 is theta 1 to theta 2, but here thetas are taken as theta naught and theta. So this is the work done formula. So work done formula here, W is equal to theta naught theta into torque into theta. Okay, work done is equal to theta naught to theta integration torque d theta. So work here, work is done by uniform electric field. on dipole. So work is here. So here work is done by uniform electric field on the dipole. So here dipole get gain energy. So dipole get gain potential energy. So dipole get gain potential energy. So work is given by the uniform electric field. So here dipole takes work. Here dipole get work. That means it is converted stored energy. That stored energy is called here potential energy. So here work is nothing but potential energy to the dipole. So potential energy to the dipole, theta naught to theta, torque formula, that is Pe sin theta into d theta. See here, two opposite forces acted on this dipole. That means these two opposite created by the uniform electric field. So electric field here doing the work on the dipole. So here work is done by the uniform electric field on the dipole. So immediately dipole get gain energy. Potential energy. See here formula theta naught to Pe sin theta d theta. Next, so we evaluate the integration here. So Pe are constant terms. Pe integration theta naught to theta sin theta into d theta. So Pe integration sin theta minus cos theta. This is the formula for integration sin theta, that is minus cos theta. So initially is theta naught, final is theta. Next, so Pe, so first substitute final value in place of theta, that is minus cos theta, minus substitute theta naught in place of theta, so minus cos theta instead of theta, right, theta naught. So we get here Pe minus cos theta minus of minus plus cos theta naught. So that is equal to Pe cos theta naught minus cos theta. So this is potential energy. But usually in most cases we take initial angle as 90 degrees, then substitute 90 degrees here, then potential energy is equal to Pe cos 90 minus cos theta. Cos 90 is 0, 0 minus cos theta. So Pe minus cos theta. So we get here minus Pe cos theta. So this is potential energy to the dipole. So potential energy is equal to minus Pe cos theta. That is Pe cos theta is nothing but P dot E minus P dot E. So this is a scalar product. Potential energy is a scalar quantity. So potential energy is equal to minus Pe cos theta, that is minus P dot E. So this is the answer. So how do you write this answer? Let's go to simple explanation. First, derive an expression. First, to take here dipole and write the formula for dipole momentum and showing this diagram. So uniform electric field. So dipole is rotated from theta naught to theta. Next, torque formula. So write the formula for the torque, that is Pe sin theta, and immediately write the formula for work done. So what is the formula for work done? Theta naught to theta integration of torque d theta. So here work is done by the uniform electric field on the dipole, that is equal to dipole get gain potential energy. See here work is lost to the electric field, immediately dipole get the gain the energy. So that energy is called potential energy. So here work is nothing but potential energy. So it is starting from theta naught to theta Pe sin theta d theta. So what is the integration sin theta? That is minus cos theta, and apply the lower limit and upper limit in this one. So we get like this one, Pe minus cos theta minus of minus plus cos theta naught. So in most cases we used initially dipole placed in perpendicular direction of uniform electric field. So theta naught become 90 degrees. See here we get like this one. Finally we get, so theta naught substitute in this equation, then we get minus P cos theta. So here potential energy is equal to minus P dot T. So this is answer.